Wow. Oh my god, that was actually the best first flight outdoors ever with a new creation. I just cannot believe how smooth and quiet and easy it was to fly this machine. I mean, it does seem super... Okay, so now it's safe. It does seem sort of over-engineered with all these parts with the, I mean, it's 4 servos and 4 motors for the control. But wow, one thing that I have been hoping for and thinking it might be so is that these propellers move really mostly in undisturbed air, contrary to the counter-rotating propeller where one blade is pushing air down to the next one, and there are a lot of these obstructions in between, and the cluster of moving control surfaces underneath to keep it and well, to make it possible for the flight controller to fly it. But this is on the contrary, the main propulsion system is just, you know, chopping completely undisturbed air except from the turbulence coming off this boom here on half of the diameter of the swept surface. And you can really notice that it's so swooshy and fluid when you fly it. So that's a really big deal actually, if well, even in this scale, but if you scale it up, there will be so much less vibrations thanks to that, and also it will be more quiet and have other desirable characteristics, such as, you know, lower maintenance, because, you know, less things reach their fatigue point, etc. But wow, what a great first flight! I did really not expect that, because it was kind of, well, it was a kind of well, not a large, but a measurable workload to hover it indoors. But of course you have all the turbulence coming off, you know, the walls and the floor and ceiling when you fly it indoors, because it's moving a significant amount of air around, of course. But here outdoor, when all that accelerated air is dissipated, it's so much easier to fly. And today it's like 2 meter second winds with 6 meter per second in the gusts. But I cannot say that I feel the gusts at all, so it's not dead calm, but it's very low wind, so that of course helps. It will be interesting to try it out later on with in higher wind condition, just to see how it works. But since it has a significant leverage to the control system up there, it should be able to fight the winds pretty easily, or at least have a good, you know, tool to counteract the wind. And it's very small surface that the wind can grab onto as well, so I think that helps. Okay, so that was the first crash-worthy test of the vehicle, and it seems all right. I will in a moment just try to restart it. So what happened is that I janked it forward and backward and want to see how much, if I could, well, what would happen basically if I'm going hard on the elevator. And at some point the force from the control system is not enough to arrest the movement of the craft, and that could easily be adjusted by increasing the power to the motors, but I cannot do that remotely. So in the best of worlds, I suppose that you would link the throttle level to the motors, these control motors, with the throw of the control stick. So when I do really extreme throw on the stick, it would be a good thing to at the same time accelerate the motors, because that signals that you are in a awkward attitude. So it would be good to have extra power to the motors as well, since the pitch of the propellers given by the servo here might be too much for the motors to handle, and they will start bogging down and not delivering the intended correction at that point. But so far, very pleased with the handling. And you can see I was just bouncing around, trying out to land hard and bad, and with slight motion or no motion forward, and see what happens. And of course, you can have such much forward momentum or lateral momentum, so that it will not be able to hold itself in the upright position, depending on, again, how much power you give to these attitude control system. Okay, so to wrap this first test flight session up, what can I say? I'm super proud over having these scars on the blade. It means that I have actually crashed it, and the overall structure survived it. The servos, all the mechanism seems to be in working order. So I mean, it sounds like a silly thing, but it's very convenient to have a structure that actually is crash-worthy, so that you don't have to rebuild it from scratch like a balsa model every time you face plant it. I had some bent parts and some loose parts here, which just happens to be balsa. But I mean, it's a super quick fix. I have more battery, so I could fly it further, but I do want to address the issue with keeping a more constant RPM on the motors to maintain the same control force across the flight envelope. I'm very pleased that the first flight, wasn't just a 5 seconds or 3 seconds jump. It actually turned out to be a chance here to actually try it up at speed, and also do the the lateral movement in all directions, both sideways and forward and backward, and just to get a feel for the structure. These are not perfectly balanced, so when I ramp them up in power, they have a self-oscillating RPM that I want to keep above, but it's totally okay because the self-oscillating span is so low anyway, so it wouldn't be flight worthy with that power setting anyway. But I think it doesn't have to be a situation where it shivers, because even if you just run one motor, you can feel it's sort of not super well balanced. I tried to balance the blades out and even the motors, but I didn't have much success with that. But again, once you come over that critical RPM, you're good. I was able to do several takeoffs and landings and get a feel for that. And of course, it's obviously when you have this kind of landing gear, you cannot have much lateral movement when you land, because it will overwhelm the control, the attitude system. So it's of course totally possible to go fast forward and just stick it down in the ground, and it will face plant itself, obviously. But again, with a more like constant RPM setting in the speed controllers, which I don't know if these ones can do that, that would surely help to catch it once it starts to go in one direction. This is the third battery I'm going through here, so normally I would just use up like a couple of % of one battery before some major issue occurs that I had to fix in the first flight. And sometimes the first flight actually never takes place because some significant issue appears when you're working yourself through the first stages of pre-flight and flight. Okay, so yeah, very happy with that. You might wonder why I have 4-blade propellers. Well, it just so happens that if I were to scale it up, I will need 4-blade propellers for efficiency, actually. But in this case, it's just because that I have a lot of 4-cells battery and have a lot of these motors. These motors are actually 2 of the motors from my 78 motor flying chair. So they're actually flying again now. And the thing is, with 4-cell battery and these motors, you will just have a couple of grams too little lift with only a 2-blade setup. But with the 4-blade setup, I can load down the motors a little more with the same voltage, and I can have enough power to fly during the whole voltage drop with the battery. So it's actually a necessity, and it actually also corresponds with the sort of tabletop calculations for the real full-scale version, which also will need the 4-blade propeller. So it's actually sort of scale in that sense, but they will be a little bit larger in diameter relative. This would be like scale 1 to 4 or so. So it's not perfectly true to that. Okay, see you in the next one. Bye.